So the premise here is still true. We have two variables. We have event A, we have not A, we have B, we have not B, then we have the row totals, the column totals, and of course we know the bottom probability is simply 1. Now, these probabilities can also be true. We don't have to actually have probabilities. They could be tables, and the table values still work exactly the same as the previous ones as well. It's the same questions. You're not finding any new probabilities, but you're going to be comparing two probabilities. And so, remember, we have the probability of A and B, the probability of A and not B, the probability of not A and B, the probability of not A and not B, the probability of A, the probability of not A on its own, the probability of B, and the probability of not B right here. And these problems, and then just to note, problems done much the same with given frequencies. More importantly, we also know that the probability of A given B is the probability of A and B divided by the probability of A. The probability of A given not B would be the probability of A and not B over the probability of not B. The probability of B given A would equal the probability of A and B over the probability of A. The probability of B given not A would equal the probability of not A and B over the probability of not A. So these ones right in here are called my conditional probabilities, which cannot be found directly on the table, but are found using those values from the table. Before I move forward, I want to make sure that everything that, or at least I've answered and given you the opportunity to answer any questions about the information that I have provided on the notes so far. So everything, the next part that we're going to do is based on understanding how to find these probabilities from the table. Any questions about why any of these values are those values? Why, this is from the formula, why those are true? Anything like that before we move forward? Okay. So as a reminder, or by definition, independence events. Two events A and B are independent if knowing the outcome to one event doesn't change the probability of the other event. In other words, and here's the rule, the probability of A is equal to the probability of A given that you know B. If this is true, then they're independent. Okay, so if the probability of A is equal to the probability of A given B, then the probabilities are equal. Now, most of these problems are actually set up. Now, what is A, which is B? Do you talk about the column or the table or the rows? It doesn't matter as long as you find two events. All right. If the probability of A does not equal to the probability of A given B, then the events are not independent. I.e., there is an association. As a reminder, not independent means association. So just as a reminder, there is an association if not independent. So all you got to do in reality is find two probabilities. If the probabilities are equal, then they're independent. If the probabilities are not equal, they're not independent. As a reminder, two events are disjoint / mutually exclusive if the probability of A and B equals 0. In most all of these problems that we're doing right now, they are not mutually exclusive because there is an intersection, there can be, but some questions in your homework tonight might ask, and the example is, are the events mutually exclusive? Well, can A and B happen? If they can, then the answer is no. Mutually exclusive means that you cannot have A and B. So that probability right here would have to be 0 in order for them to be mutually exclusive. That top left box. If it's not 0, then the answer is no. Questions? All right, let's get to the example. So I'm going to pause it really quickly. Here's the problem that we're going to have. If you want to do question 1, and then notice that I gave space on this part because we're going to draw a table. Basically, we should be doing tables for the problems that we're going to be doing. So for this classwork handout, I have this. I'm pausing the lecture. So those of you who need to write the question down because you couldn't print it out, or it just seems easier just to write it down anyways, have that time. There's the question. If you can, I'm going to give about 2 minutes to write the question down and maybe attempt the table before we do the table together. All right. So during this pause, please complete Make this table. I don't need that top one. You know, the full probability is 1. All right. How should I label the top row? This is where I need your assistance. How do I fill that top row out? Now I do note that the answers may be transversed, which means the rows might be the columns, or the columns might be rows. I like typically to start with the columns, but you might see my solutions being the rows, but in the end the answers will be the same. Basically, I want to make sure that we can all walk through this example together. And so I'm going to be very diligent about waiting and having you inform me of the responses. How do we want to represent the top values or the top parts of the row? Did your homework, which is the only way you can be passing this course. Should be very easy. You're not doing your homework, you're not passing this course. Be very diligent about that this term. So let's get going. How do I do it? That's what you're going to have to be doing for all your homework problems tonight again, just like you did for your homework last night. And you were given them for them the homework the night before that. School night, work night. So the who is biology majors in their junior year. That's what I get from there. Remember, just like for almost the first day of listening on the first problems, identifying the who and the what of the problem. So the who, biology majors in their junior year, and what is the what? What are the variables? What do I want to know about these juniors who are biology majors? What do I want to know? They're all juniors. They're all biology majors. What is the variables? What are the variables? We have to go, we're going all the way back basically to day 1 of AP Statistics here. The variables are stats, statistics, or computer science, a computer course. So we'll call it stats and computer. So for each of these questions, they're categorical, which can mean yes or no, yes or no. So I ask again, after 10 minutes, how am I going to label the top row? S and not S. So have they taken stats or have they not taken stats? And you're missing the top far right. What do we write on the far right? It's always the same on every single problem, everybody. Come on. Total. Okay. What do I label the left column? C or not C? Have they taken computers or not taken computers? And you're always missing that last one. What's the bottom left always?
Total.
Total. So those tops and lefts, the bottom right is always 1. The top left is always not used in our tables, just an open space. The top right and bottom left corners are always totals. And then we have the context of our two variables. These are always two categorical variable questions. So identify what the variables are. The variables are stats and computers. Those are the two variables. And for each of those, the answer can be yes or no. And we abbreviate that with S or not S, squiggly line, and C and not C for computer science. We have not taken any numbers. These are the same things. And like I said, this is how you should have been doing last night. And the reason why maybe I'm being a little bit like, oh, why are you so pushy and why is he so? I had the solutions up there for the previous ones, and since I had no questions, it really, really worries me. And if I have to fail a lot more individuals this term because you're not actually doing the homework, then I will do so, because that's telling me that there was almost no questions, even for those who did complete the homework. It was to not have those questions. It's very, very, very worrisome. Now we will fill in the information. All right. So box 1, 2, 3, 4, 5, 6, 7, and 8. All right. Let's say these are my 8 boxes. The first information says 52% of the biology majors have taken statistics. Which box does that go into? Which box am I going to place something into? Box 1, 2, 3, 4, 5, 6, 7, or 8. Where does that 52% apply? No, it is not box 4. It is not box 2. Notice that it does not mention computer science. So when something, in order for it to be boxes 1, 2, 4, or 5, those 4 boxes in the inside, we call them, in order to be one of those 4 boxes, it must mention both variables. This question only mentions the variable of statistics. So where does the total for statistics or the response for only statistics go? It is not 3. Statistics. 52% of students have taken statistics. Which box is that? We've eliminated 3 of the boxes. It is not 5. Once again, it does not mention computer science. So it cannot be any of the computer science. Computer science is listed in the rows. So because this question does not mention computer science, we can eliminate 1, 2, 3, 4, 5, and 6, and there's my answer. It is 7. It does not mention computer science. Therefore, this 52% represents 0.52. If you were reading this table and doing this problem backwards, and I said, all right, given now, if I gave you this table as is, what's the probability I randomly select the statistics students? It'd be 0.52. All right. As a reminder, 1, 2, 3, 4, 5, 6 are box 8. Next one says 23% of students have taken a computer course. Where does that go? Doesn't mention statistics, so it can't be any of the upper 4s. It is box 3. There we go. Now we're making some movement here. 23% have taken computer course, so that's 0.23. All right. Box 1, 2, 3, 4, 5, 6, 8. Out of these 8 boxes, the next one says 7% have taken both. So that means they have taken statistics and computer science. There we go, box 1. All right. Box 2, the one next to it. Let's go into box 2. What does box 2 have to be now? 0.16. Good, they have to add up. 1, 2, 3. Box 4. What does box 4 have to be? What does this box have to be? Just plain Sudoku here now. 0.45. Perfect. Just some simple math now. 0.45. Box 5, we do not know what it is. We have to do that one last. Box 6, the far right, the other column. The far right column. What does that have to be? This part should just fly. Basic math. Basic as it goes. 0.77. And the other total one, this one down here. Now we could now answer 5. We could answer 5. But I like to do the totals first. So what does that box have to do? 0.48. And the last one, you can go add them up or down, left to right. Really doesn't matter. It is here. I'll give you the starting 0.32. Perfect. All right, fill out my table. That's just step 0, everybody. All right, we spent 20 minutes on that. It needs to get down to like 3 minutes, 2 minutes, less. It should only take you about 1 to 2 minutes to be able to take that information and create the table, especially when you know you're making a table. So this question's asked, the first question's a little bit different because it says the prerequisite course is that the students must have taken either statistics or computer. So to be ineligible, you are ineligible if you have not. So this question is asking, what is the probability that the student has not taken a computer science course and not taken a statistics course? They have not taken either. If you've taken one of them, you're okay. So you're ineligible if you have taken neither. So what's the answer? The answer is on the screen. This is a basic last night homework question. Just matching it up. We have 32%, but of course we write 0.32, just leave it as 0.32. The answer is right there, not, and not, give me that answer right there. Next question, what's the probability that a junior biology major, which everybody is, everybody gets confused on. The hardest part about these questions is when you think that a junior biology is a given, but that's everybody, has taken statistics. Who has taken statistics has also taken computer science. Now, the wording here, this is a conditional probability. So this is a conditional. So this is the probability of what? This is the toughest part of the whole homework, I think. This is the probability of, we know it's a conditional. What do I want to know? Have they taken what? Have they taken Computer science, yes. Have they taken computer science, but I know they've taken stats? That word who means a biology major who has taken stats. I know they have taken stats, given stats. So this one is the probability of computer science and stats, which is the intersection of computer science and stats, which is 0.07 over what? The probability of stats. What's the probability of stats? Taking this way too long. 0.52, good. Which gives me 0.13. Are these two disjoint? Yes or no? We got 2 minutes. Are they disjoint? Yes or no? Can they close? Or there's only 50. The answer is no. They are not disjoint. The probability of C and S is 0.07. So you can have them both occur. Disjoint means they cannot. All right, it is not equal to 0. You could have also said C and S does not equal 0. That's basically what we're saying. Are they independent? All right, we're going to use the information they've already given me. We already know that the probability of C given S is 0.13. What's the probability of C? What's the probability that they take in computer science? What's the probability of taking computer science? No. What's the probability of taking computer science? Zero 0.23. Are these equal? Are these equal? No. So the answer is no. The probability of C does not equal the probability of C given S. And that's it. 10:01, that's the end of class. We got some work to do, people. Tutoring is offered tonight. All right, tutoring is offered tonight. I'm going to send these notes to the class, to the tutor. If you have not attended Tuesday night tutoring, I highly recommend it. I recommend every single one of you be there based on the feedback I was getting in terms of the teeth pulling we had in doing this classwork together. All right. All of your problems are basically like this. The final problem actually only asks you this final question. For every problem in tonight's homework, start off by making the table. Once you've made the table, answer the individual questions that are asked. Typically, one of the questions will be a conditional probability like part B. Sometimes the only question that gets asked is part D, and I believe that's only on the final question. That's what I have for you for today. We got some work to do for probability, people. We probably still got another 2 weeks to go. So let's put the work in.